Hello developers, let's start developing. Today we're gonna take on the 14th day of the 2023 Advent of Code, and we can see we're at the top of the mountain. So I guess that this is the last island that we're gonna visit, or maybe there will be some more as we are about halfway there. However, we need to fix some kind of reflector dish that does some work to get some energy, to get the lava, to get the gears, to get, and so on and so forth. What the task actually is that we have a matrix, and I hate matrices because there will be a lot of index management. That is always tricky to do. So we have some matrix, and on this matrix we have these characters, the O characters, and the hash characters. So the O characters, those are the empty spaces. So the hash characters are immovable rocks that just stay there. And the O characters are rounded rocks that can move if we tilt the matrix, so to say. So we can tilt the matrix in any direction that we want. We have north, east, west, which I will rename. So the first thing that we're gonna do, I'm gonna say we have a type direction, which is not gonna be top and bottom now. It's not gonna be this because it's not actually contained in input, but we can have that we are tilting. We're not gonna be tilting, we're gonna be, let's say, attaching or magnet or something like that. So basically up will mean that all the O's get up, or left, or right, or down. So we have up, down, left, and right. Those things I can kinda understand. Northwest, I've read a bit on Reddit. There are a lot of people complaining, oh, my code was great and it was fun, and I just messed up east and west. So let's not do that. If we mess up, we're gonna mess up left and right. And even I get those moves correct. So after we do that, we need to do some kind of a calculation. So basically, any O rock on this line gets a 1 point, on this line gets 2, 3, 4, 5, 6, 7, 8, 9, and 10, and we add them up. So that's all that we kind of need to do. So let's try to solve this. So we have, this is our starting point. We have a 10 by 5, 5, 10 matrix, so we need to read it. So we need to say, okay, a cell will always be a, well, not this, give us a kind of a guess, but a cell will be one of these options. So we need to read our matrix, and so the matrix will be a, yeah, it will be a cell array, which means that we need to return. So we can say const else is lines.map, lines.split as cell, something like that. We're gonna use the print matrix method that I have. So let's just see if we are able to echo. By the way, this is a run of all the tests that we solved so far. Task 12, part 2 is not done, everything else is done. And even without part 2 solved, it's taking up 56% of our runtime, which is not a good thing. Anyway, we can say, let's start the 14th task and see what happens. we are getting this, and I will just compare whether this is the same input we were given. Yes, it is. So we successfully transformed it into pieces, and then we successfully reformed. And we have those O's and everything. Now we need to do a tilt up. So I will implement it this way because we're getting an input and then we're getting the cell as an. Yeah, we might need to do something like this in order to copy it. We can just use slice here. We don't need to map it, but we're not gonna call it new input. That's a silly name. We're gonna call it cells. Why not? So we don't need that. We're gonna say cells, cells. No, we have rows now. And we're gonna use, do we need too much X's and Y's? We might, but if we do it this way, we are using some kind of a weird coordinate system, which means the X is in this direction and the Y is in this direction. So it's like a regular X and Y coordinate system, just flipped for in 90 by 90 degrees. But anyway, I always want to say we have a line, a row or a line, which is that thing, and then we run through the row. And we need to find all O's and move them up. But actually, I might want to do one other thing that will be a bit wasteful in memory, that will provide for a bit easier code. Well, because basically we need to take an O and push it up, at least it comes to the top or it comes up to a hash. Because this line, this O, for example, if we're pushing it, it goes here, it cannot go here, so it stays here, and here it is. And this O goes up, 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 and it gets here. So what I will do for tilt up, I will actually say that is the matrix, but on that matrix I will add an empty row at the very top. So that will be have the length of input of 0 length, and we will fill it with rocks. Actually, it's not an empty, it's rock row. Rock row. So let's just do that. Let's see what we made without returning anything. So instead of doing this, I will say just tilt up. Okay. It should give me the same thing as the one we had. Oh no, not console log it. We need to print matrix. It should give me the same thing, but with a row of rocks on the top. Beautiful. So now we need to push all the O's as far as they go. And if we go from the top down, this we cannot push. Not do nothing, do nothing. This we cannot push, this we can push. We are pushing it, this we can push, we are pushing it, and so on and so forth. So yeah, that will work. So now we can say, okay, look through everything. And we can say, if it is a, not a zero, an O, and not a lowercase o, up. Actually, I will, since I don't write well like code that is too nested, we will just continue. If it's an O, we are just continuing. We don't really care. But if it's not an O, if it is an O, we need to see the one above it. And we know there will be one above it because we added above it. So even this one, which was on the corner, now has a rock above it. So we don't have to do any checks, but we can just say, is the one above it, and that's not +1, that's -1. Clear. Actually, I will say something like, let x move equal x. So we're moving it from, and we can say, while input of x move is no, this is the wrong. But while the input is a dot, decrease it. So one up, one up, one up, one up, one up, one up, until we get to a point when we have a rock or a hash rock or a O rock. Doesn't really matter. If we get to a rock, we're stopping. And since we're going the first row first, and then the second row, and then the third row, if we had something in the rows above us, they will already flow to the top. So this means that now we just need to swap them. And we can just say, if x move is not x, that means that this code executed at least once. Oh, no. Because otherwise this will crap up on the first time. So what happens? So we're doing this. We're starting from the row above us until we get to a row that's filled. When we get to a row that's filled, we go one down. Then we just swap those cells. Which means that basically this this rock. This cell will become an O and this cell will become a dot. And throw away the first row. We don't need it. We just added it to be cool. Let's see if this is doing something. It's possible that we got it right. It's possible that we got it wrong. Well, we seem to gotten overboard because we have a saying that when you're looking at one thing and acting on another, but yeah, this is what happened. We intentionally created cells to avoid working with the input, but then I pasted input from somewhere. We should not touch the input unless we're making the copy. But when we have the copy, we work with the copy. And this looks kinda okay. Yep, we got our solution. And now we only need to do this, to do the calculation. So we can add yet another method. Calculate weight. Don't need that, we just need our cells. And what we need to do, we need basically to count how many rocks we have in each row. That's okay, and then to multiply them with something. So we can say cells dot map. We are mapping each. We can do it with reduce, but I will use in multiple rows so that I can know what I'm doing. So we're mapping to row filter cells that are O's, uppercase O's, and we need the length of that. And then we need to map that count times what? How many rows that we have? So cells dot length. Oh, length, but the other way around. And we need to have the index. So we have a count index here. We can take and we can multiply the count for the, so this has 10 rows, and for the row number 0 we need to multiply it by 10 minus 0, and then we have to do 10 minus 1 until we get to here when it's 10 minus 9, which is 1. So we need to do cell length minus index, and since we can just sum this up. And we can just return this. So we have the cells. Let's weight is calculate the weight of those cells and return the weight. We are looking for 136, if I'm not wrong. Yes, this is the number that we're looking for. So we're tilting the platform so that all the rounded rocks roll north. What is the total load on the north support beam? It's 136. Great. Let's take the real input, which seems to be a bit of a bigger matrix. So it has a 100 by 100 cells, which means we have 10,000 items. A bit more than the 100 that we worked for, 100 times more actually. But let's see if the processing is fast enough. It says that the total weight is this much. And to be honest, I'm quite curious what second part is. I've seen that it will be something with huge numbers. Let's see it. The forms, but not in a way that focuses the banana. You'll need to move the rocks to the edge of the platform. Spin cycle. This cycle 4 times. Rounded rocks roll north, west. Let me just do this once. So we have North is up, and then west. West is in the direction of Spain is on the west of Europe, so that is on the left. And then we have left, and then we have, I guess, down. We'll need to check that. Northwest, south, down, and then right. So those are the directions that we will need to tell. Which means that I will need to create 3 more methods. And to be honest, since we're working with matrices, I would prefer those to be separate methods because we could have a lot of errors with all that index management. They will be very similar, but I'm not gonna generalize it. I feel more comfortable with 4 different methods. We'll have finished running those 4 directions in that order. Each of the first few cycles. So after 1 cycle we have this. After 2 cycles we have this. After 3 cycles we have this. After this many cycles. Let's see how many is that. That's 1000 millions, or some will say a billion. Well, not that much, but it might take some time. For example, if we just count to that many and do nothing, if this doesn't get optimized, then let's just say let x equals 0 and x plus equals 1, and then so that it cannot get optimized. So we're basically just counting up to a billion. Let's see how long that lasts. It takes a while. It takes 2 seconds to just count to a billion. So now we will need to do something more complicated than counting to a billion. We will need to do something like, let's say, and I might be sorry for implementing this in an immutable way. But on the other hand, I don't think that we're gonna need to run the full billion. Usually we don't. So let's say cycle not let cells equal, we're gonna take input and then map line slice to actually copy it. And then we can just say cells are tilt up cells, cells are tilt left cells, and let's implement those as dummies. Return input, so they're not actually doing anything. Tilt left, tilt right, and tilt down. Tilt left, tilt down, tilt right. And let's use a smaller number first, like 1, to actually see what is happening, because we will say print matrix. But first of all, we kind of need to go to the smaller input to see what is happening if I do this. So if I just run it, it will just tilt up. And now let's do a bit of dangerous copying and pasting, because the down will be similar but different. for this. So we just need a row of rocks, but the row of rocks needs to come at the bottom, not at the top. And we shaped a dot somewhere. And we cannot process the rows in this way. We need to process the row in the other way. So x will be cells.length minus 2 because we don't want to process the row. Actually, we don't mind. I like this better. This will be a bit slower, but just like here, we're actually processing the row that we just added that has only rows. This will run for that. We can optimize it like this, but let's save that if we need to actually do nitpicking. Right now, I can think better about this loop if I don't see a 2 here. And x will be bigger than or equal to 0. And x will go in the negative direction. We don't care about y. We basically don't care about y because when we're thinking about rows, every column is totally independent. It doesn't matter in which order we're passing them. We can then pass them basically in a random order and it will still work. Because you can see the y is a constant here and it's independent. So this part stays the same. We're getting the row and then we're getting the cells. We have x move. It will be +1 and we're going to be going even more positive. And then we're going to remove 1. And then we have the same thing and we need to return slice from 0 up till this many. So we just need to do the last. Let's see if this works. So we're just tilting. Let's comment everything else out. So we're taking our original thingy, our original cells, and they should, maybe we should have called them rocks, but we'll see. So we will need to tilt it down. Let's see if this happens. Our initial thing is this, so which means that if they go, they will basically stack here. The second line, they will go down. This goes down, hits here. This goes down, hits here. Here, hits here. Those are over there. And it looks like we've successfully tilted down. Okay, now the scary part, when we have to do the column-wise thingy. We're gonna try to implement the left one. So we need to do a column of rows at basically position 0. So we don't need this, but we're gonna need to do something like this. We're not changing the rows, we are changing each row by a bit. So instead of this, we're gonna have to do, well, add a hash and then add a hash and then add the line itself. We don't even need to use a slice here because it's superfluous. This will kind of do the slice for us. And now I will copy over this part. Because it looks better, but I will move this here so we are running on the Y first, and this can be just cells of 0. We don't need to check whether we have 0 because otherwise we have some deeply messed up input. And this is the column. And then we run X along the column. Let's see, along that column. So basically, the column will have these values in a given column. So we have this and this and this and this and so on. So we have we don't even need the column. We're using cells all the time. We can just say cells.length. That's how long a column is. It has the exact same length as cells. So we can say if this is not an O, continue. Otherwise, we have a Y move, which should be Y minus 1. And then we're doing this. So we're going to do the Y move on the X. And we're starting to lower it to get it as left as possible, and then we do the same thing here, only we're not doing this, but we're doing this is XX, this is Y move and Y. Looks like it. And now we just need to return something else again, this. So we're taking the lines, and out of each lines we're just throwing away the first row that we had. Again, we can do that with a bit more complicated checks, but I don't want to do it right now. We might optimize this later. We might do in-place changes if we want to have it better, but now I would rather have a correct solution. What is this? This is a string. Yeah, this says line is technically. Oh, just a sec. We need to say that this is an array of cells actually. It is. So we can now tilt left all the cells and see what we get. They should all get to the left side of the screen. So we have we have this is different. This should drop down. Yeah, yeah. Looks like what we wanted to happen happened. And now, same thing, only different direction. Let's have this as a pattern that we'll need to do. So instead of this, we need cells of 0 dot length minus 1. Bigger than equal than bigger or equal to 0, and then we take the negative route. Okay, what else needs to be different? Well, this needs to be different because we're not adding a rock at the beginning, we're adding a rock at the end. This doesn't matter. We can run the cells however we want them. Same reasoning over there, only we're moving right. So this is a plus, and this is a plus, and this is a minus, and everything else is the same, except here we need to slice the other way around up to here. Let's see if tilting it right actually is doing something. There might be a small bug in any of these functions, and I want them separate so we can basically debug them separate. So that moves to the right, that moves to the right. Seems that in all the cases we are moving as far right as we could. We preserved everything else. So yeah, let's do this. And here we have in the example, we have after one cycle, after two cycles, after three cycles. So let's do that. Cycle count of 3 and print metrics and then just console log. And do an empty console log before that. So we just get an empty line. We want them visually separated. Otherwise, we just get a bunch of hashes everywhere on the screen and nobody understands that. So now we have nice. This is a single cycle. Let's see if that matches anything that we see here. So the first cycle went correct. The second cycle went correct. And the third cycle went okay. And is the third cycle different than the second cycle? It is. This say it is. Yeah, it's like this. But I have a feeling that the cycles, we're gonna get to a fixed point somewhere. So we don't need to actually run 100 million times. 1,000 million times. A billion times. We don't need the X. So for the small thing, let's check it out. So if index is divisible by 100,000, let's just log the index. And otherwise, we just need what we need to do after we tilt it this way and that, after we shake it around, we still need to do the calculate weight thing. So this part is identical. So instead of running it 3 times, we're gonna run it a billion times. We might need to wait, and I might go out for a small break. So this inputs every 100,000, so that means 10 of them are a million, and we need to wait 1,000 times like that. So we have 20 seconds for a million, which means that we will have 20,000 seconds for a billion. Note that the complexity doesn't actually change. We're still running the same thing over and over again. And this spends a lot of memory. After a while, we will get some problems that because we're creating a new array, a new matrix every time, and we're ditching the old one. So if we did in-place changes, this would work better. Anyway, we need 20,000 seconds, which divided by this many, it's something like 6 hours. 5.5. Which I'm gonna kill now because it's too long. But what I can do I will remember all the possible configurations and see if they are the same. Because if we get to one configuration that, so let's say for example, if cycle 7 and cycle 8 give us the same result, that means that cycle 9 will be identical, moving from 8 to 9 will be identical as moving from 7 to 8. Or the same if cycle 7 and 9 are giving us the same result. That means going from 9 to 11, it will be just the same as going from 7 to 9. For that, we can just say, let's create some kind of a cache, which will be a new map that will have a number, and it will have a, now let's just have it as a, I want to create something that will represent this. But how do I represent it? Well, I can have it as a long string. Who cares? Let's just have a set of string. So this is a bad way to do that. So kids, don't try this at home because I will be wasting a lot of memory. But this is the baseline that we want to accomplish. This is something that you want to do. I will add a new method, cells to string, which takes this and does this. It's a simple method that will basically print out everything into a string. It will just plop it in. It's gonna be an ugly string, but I will do that. And we're not gonna do this. But for now, I will just say if cache has the key, found cycle at index, otherwise add the key to the cache. And let's run it for a while. We might get lucky. In this specific case, it may say we have a cycle on the 10th item, or it may say we have a cycle at the 1000th item. And might have been a good idea when we found the cycle to actually break it, because if you find the cycle, you're going to find the cycle again. And we're actually adding it over and over and over again, and it doesn't get added because it's already there. But still, let's see it. Found cycle at index 9. Let's change it a bit. Let's have a map of a number and a string. And not this, but I'm writing something that's not really optimal. So I'm getting all the values of the cache. And now we can say, no, we don't want it like this. We want the ID as well. Yeah. Let's say that if find this index match with found one, something like this. So I want to see what actually happened. Cache dot set index and key. So this is some sloppy code, but I plan to run it once, so I don't really care how fast it goes. I just want it to be correct. Match with the second one, because we might need this, and you can see that I did that. So this means that the second situation happened at the ninth item. So that means that we have a cycle that has a leading of 2, because we have the first cycle, the second cycle, the third cycle, and actually it's index plus 1. So it's not the 9 and 2, it's 3 and 10 actually. So the third one, something happened. And then on the fourth one, on the fifth one, on the sixth one, on the seventh one, on the eighth one, on the ninth one, something happened again. And then on the 10th one, X happened again. Which means that we will once more go through this. 10 will give 11, 14, 15, 16. And on the 17th, the third item happens again. Because that's once more X. So that means that now we need to say, let's say, what will the 100 be? Because this is a cycle with a remainder of 3 or something like that. So we have actually these classes. We just need to do, only these are important. We can discard these two. So we have a cycle length of it's gonna be this much. We have this many remaining things since we're doing modulo. No, we don't want to do this. Let's just console log the cycle length. Because in this case, with the cycle length should be actually 7. Yep. So let's change this a bit. Now it should say I found cycle of index 9. Did I mess up the printing? Because it says I found cycle of index. We found to find the cycle of index. Index 10 match with 3. I don't really want to look at this, but what I do want to look at is what happens with the big input. Now we have some boring modulo mathematic to take care of, because we will get it wrong at least once. But I want to see how long a cycle do we get now. Do we get a cycle of 10,000 or do we get a cycle of 7? It says found cycle as index 112. It matches with 103. And the cycle length is 9. That's cool. Which will mean that So let's solve our problem that we wanted to do. What will be the cycle length of 100? First of all, to get to the cycle, we're gonna remove 2. Because if we remove 2, we're starting the cycle from the cycle start. We can say that the third run is the actual cycle start. And then we can say, what is this number modulo the cycle length? That's 7. It's actually mod in Excel, I think. Oh, 98 is divisible by 7. 49 and 49, 98. So this is 0. So if we have this plus 7, we'll get 23, 30, 37, 44, 51, 58, 65, 72, 100. Yeah. So we get a 0. So after the 100th cycle, we will have the exact same situation as after the end of the cycle, because the cycle starts with 3 and ends with 9. But 9 is the last original thing. So what we need to do, going back to the small input, because we'll need to see, we need that, we need most of this, but out of this we kind of need, we don't need this because we never got 1000. So no, the cache size, we need the cycle length, and we need the cycle start. Is found of 0. And these need to be actually returned, kind of here, so we could just say let cycle length 0, cycle start is 0, and we're just setting them here. So we have the cycle start, we have the count, we have the see. Yeah, let's give this a name a bit later, but now on the cycle count, we're gonna remove the cycle start, and then we're gonna do a modulo cycle length. And we got 0. So if we got 0, so let's say if we have 200, this will be 198, and this will be 2. We already have this in the map, so we might just need to take them out of the map. And speaking of the map, I will just add a pipe here. You'll see why. So the matrix at the time of 100 would look like the matrix at, we have a cycle start of 3 and a cycle length of 7. And a reminder 0. So this will actually take 3 plus, no, let's set this plus this. That gives us 10, and that is the wrong answer because we want this. Minus 1 minus this. let's just, oh, come on, it's not B12, it's B11 and B12. So this says it needs to be 7. Maybe we need to plus this. Yeah, I think we need to plus this. So to the 3, we add 7, and we add that, and then we also might need to do a mod. With the 7, so that we get that this should be the 4th one, and if we do this on, if we do this mod 7, we will get the wrong answer. Because this will say 2. And 2 is not playing. But on the other hand, if we instead we add 7 here, we will get 2 again. We need to get 9. For this, I'm quite convinced that we are okay. Because if we just continue running, I'll move this away here. Yeah, that was smart. So if we just continue running, we will eventually get to 200. Yep. So the formula is kind of correct, but it fails for the 0 case. And we cannot add. We need to modify it. Maybe what will happen if we say that this is 4? No, it's not starting at 4, it's starting as 3. But we can pretend that it starts at 4. Why does this change the... Oh, we'd have a wrong formula, because this shouldn't change. Oh, it will change here, because this is minus this minus 1 plus 1. So if this gets 4, this will be 97. So yeah. That's how we get that. So if we say that this is 4, this is 5, this is 6, this is 7. If we say that this is 8, but 3. It doesn't really matter where it starts. Well, we can just say that if we said that this is 7, yeah, it's still. So if it's less than the cycle start, it's the cycle start plus the start. Who really cares? And do we actually have a 0 here? Let's see. Let's write out xxx. If it's a 0, we will need to add a bit. Otherwise, we just need to return a value. It's not 0, it's 3. For the small input. And let's see what it is for the big input. Only if that is a 0, Is my code correct actually? We are removing cycle start and we are adding cycle length. No, we needed to do this if you remember. But the loop was 9 and this answer is 6, so this will just move it over to 7. Yep. So we don't really need to take care of it. So this x gives us this number. And now we need to calculate this number. So we need to this is again B12, which means that if we have B12 there, we don't really have it here, move it here, because that's modulo 0 by definition. So we just offset it. Yeah. So we add the XXX number to our start. And remove 1. I guess that is correct. Let's log that. And then we just need to say the matrix is something like that. And actually, once more, we need to do the cycle length, and we don't need to add +1 here. I don't think. So we're getting an array of, actually no, we can just get it. And this is a string. And we can now say cells string to cells. We're getting a string and we're returning cells. We're gonna split on the pipe and then map each line. So this will return a cell array, a matrix. And we're just gonna say string to cells of that. And we know that we have it, so it's not gonna be a problem. And then we already have that, but we will have cells, so final cells. And we just need to say that that is that. Let's see if this is maybe correct for the small input. I have a feeling that we're off by 1 somewhere, because everybody hates mod math. I would say about even odds that we are correct. It says 4, it says 6, and we are returning 64. We might have gotten it correct. We did spend some time thinking about it. So this is the actual map index, and this is the cycle index. The problem is that, yeah, this is the index in the cycle where we want it to be. So this will be the zeroth, the first element of the cycle. This will be the third element of the cycle. And the zeroth element of the cycle is 2 plus 7 in this case. so it will be 9. If it's 0, it needs to be more. So we can even do that. We don't have to. Only if this thing says, if so we can, I will, yeah, something like that. We will need to move it away. But I don't think that we have that case. Actually, I know that we don't have that case. If we had it, we would have needed to write one more line of code, which will be again with lots of pluses and minuses. And let's see what we get for the huge input. We do have around 100 lines to run, and it says it's 104,000. Let's see if this may be the correct answer. And it's not. Most likely we are off by 1. I'm quite confident that this is the correct solution, but let's try to tweak it a bit. So what I will actually do, we have a lot of matrices in our cache map. I will just run some more exploratory development. So we have all of our thingies, and we can say cache. Not clear, but get the entries. Actually get the values. Put them in an array. And not for each, but just map. We don't need the index. Now I just want the values because these are strings, and we will want to call not that, but the nice method string to value, and then map it again. Cells to calculate weight of cell. And actually, what not? Just add the that. So we're gonna map it to an object that will have index, which is a value of 0, and cells, which is a this thing of value of 1. And we need to have that line and that thing, and now it's okay. And now we will need to remap it to something that has the same index, because this is an object that actually has as index cells, and then we use the same index, and we actually have a way GHT property that is this, and then we need to close that over, and then we are full. Yeah, this looks like some random characters, but oh, this looks even worse. 1, 2, 3 types, 5 characters, which are 3 different types of parameters. Because there will be many of them, let's just see them, because we have that it's not this much. And it's not a good idea. If we are off by one, now I will literally try the values that are each side of this, because I am not gonna bother with how it's going. Is it running? Oh, yeah, it is. But we've gotten something different. That should be a number. Now let's call this wave 2, wave 2. It's just a one-time thing that we're gonna need to take a look at. I don't mind giving ugly names to variables that I know that I will be deleting. Eh? This is the first wait after a single cycle. So we might have gotten totally lucky on that one. And our code that we wrote with the cycle starts and whatnot is totally bonkers. Found cycle as index 112 matched with 103. So from 103 to 111, where is 112? Are we starting from 0 here? No, we're starting from 1. Where is 1? 112. Or did we find it on? Yeah, but one. We don't need 112. So one, this 3, 4, 5, 6, 7, 8, 9. These 9 are the cycle. So the answer should very much be one of these values. What are we doing wrong? So we have our in the index within a cycle. And an index within a map. No, I am totally wrong. Let's have some more cases. Yeah, we need to basically say that this B11 thing is fixed. So that is that. And yeah, 4, 5, 6, 0, 2, 1, 3. And if we, and B11 is again fixed. Seven. Yeah. I'm a bit on the stupid side, because we just need to do something that is way easier instead of this. We have 2, 3, 4, 5, 6, and we just need to add the cycle start. Because the cycle start is from 3 to 9 and we have numbers that are that. So we need to move it over. So it goes 5, 6, 7, 8, 9, 3, 4, 5, 6, and so on. So the actual, this is correctly, this is the cycle index, but the map index is just the cycle index plus the cycle start. Not even -1. It's just that. So we did calculate everything correctly, but we got the map index wrong. Let's see if this gives us some value, because the correct value seems that it will be one of these. We didn't actually write. Yeah, one of these. I have no idea which one, but it should be somewhere in the 90-ish. And this says our answer is too high. And that makes sense because our answer is actually this much. Let's see if this is the true answer or we need to do some more digging. That answer is too low. Okay. So a good thing is that we have only something like 10,000 numbers, which could be our answer, but I'm not convinced of that. I think that it will be one of these, even if we have to actually check all of them. So it says that it's this one. So next, this says that this answer is too low. So we're looking for something higher than this. So this is off. Next, we're trying this one. But I think that now I will have a block of 6 seconds. Hopefully those 6 seconds passed by now. Let's see. And that is the right answer. I'm gonna now it says that thing. Let's try it with the small input, because an especially annoying thing with advent of code is when your app code actually works for the big input but doesn't work for the sample input. Give me 64, otherwise I might go crazy. Yes, this is the correct way. Let's play it once more with the big input so that we can have a runtime. Actually, I'm just gonna run all of these and see what's happening. In the meantime, we can return to the advent calendar and see that we actually have 27 stars. The start for the second part of day 12 is still missing, and our code is actually running right now. So this is one of the smaller, since it said that it only uses 3% of the processing time, but 12 is still a problem. Task 12 is still a problem, and we have an optimization pending on this as well. We'll see how the other tasks turn out, but we broke the 10-second barrier. So keep developing and we'll see each other again.